So, welcome everyone. Welcome to this designing and building disaster recovery solutions in Windows Azure. So, how many of you use Windows Azure? Nice. How many of you have DR implemented in your solutions, even on-prem? One at a time, please. Okay, nice. Okay, so first, starting a little bit about me, my name is Nuno Godinho. I'm Portuguese, living in London. I work in the DD Technologies with Wade, Ryan Dunn, Michael Washam, Michael Collier, and so on. I'm Director of Cloud Services for Europe, so I focus mostly in Europe. And basically, what we do is helping customers build the cloud strategy and actually implement it. And sometimes we get these crazy ideas of, hey, you should have a disaster recovery solution. And people tend to ask, why? It's everything in the cloud. The cloud doesn't fail, right? Does the cloud fail? No, of course not. Okay, so during this presentation, what we're going to be talking about is first a little bit of introduction to disaster recovery and some terminologies and some important considerations. Then we're going to look at some of the DR options that we have and how they are in theory and how we can actually implement it in Windows Azure and see some consideration during that. And to finalize, we'll get a little wrap up into what we should never forget when doing DR. And the key takeaways are actually to outline that there are some architectural patterns that you can use and will help you to create highly available, fault-tolerant applications. Because when you think about the cloud, Windows Azure or anything else, one of the things that you need to know is my application fault-tolerant or not? So it's important to understand how my application recovers from some failure. Is it going, for example, imagine I'm doing a banking solution, and a typical process. I'm sending money from one end to the other. Is my application fault-tolerant? If, for example, I stop in the middle of the process and I restart the application, and he already did the part of withdrawing money, but he starts all over again, and so we withdraws money 2 times and only places on the other account once? Is that acceptable? Is that a fault-tolerant application? No. So it's important to understand the best practices of implementing and understanding how to choose and what impacts do they have. So, in introduction, one of the things is, what is disaster recovery? So let's make this a little bit interactive. What is disaster recovery? Anyone? So the ability to keep the application up and running when the data center or the application or something goes down. Yes. So how many of we have this as our disaster recovery? It actually works. It actually works. You should have seen some interesting customers I work with, which they have a brilliant disaster recovery. Someone actually starts running from one end to the other to kick someone. It's awesome. But disaster recovery, when you think about it, is exactly that, preparing for failures, getting ready, having a process in order to handle the failures. How do I handle hardware and software failures? For some reason, those things still fail today. There's nothing that the cloud did in order to solve all of those problems from hardware and software. Just made it easy and quickly to recover. And by doing redundancy, it provided that also. Network, power outages, physical damages to buildings. That thing happens. And there's one that you should never forget. Humans fail. Humans fail. There was a story, probably all of you already know this story, about one place that the data center went down every day at the exact same time. And there was a lady that was doing the cleaning that actually needs somewhere to plug the vacuum cleaner. So she unplugs one thing and plugs the vacuum cleaner. I actually saw that in an hospital. It was so great. Fortunately enough, it was not the life support process, because that would be a little bit bad. But yeah, some things, people do some crazy stunts. So it's important to invest time. It's important to make those elements, prepare, rehearse, test. One of the parts which is extremely important when you test applications in the cloud is testing for disk cases. There's actually solutions like Chaos Monkeys. Who already heard about Chaos Monkey? Chaos Monkey is basically an application you put in your environment, and it basically starts crashing things randomly. It's a great way for you to test if things are fault tolerant or not. There are several implementations of that, several ideas around that. And this is a continuous process. This is a continuous improvement process. We're never done. And then there are some things like recovery point objective. What is recovery point objective? Exactly. So basically, is the point in time that is okay for me when I last did my backups, where I last have my application and data running in a good state. So my RPO is going to be this time. One of the things when we create the DR capability and DR strategy is to define both the recovery point objective. So for me, how much time can I handle if I need to roll back? 5 minutes is okay, rolling back 5 minutes and losing that portion? Okay, that's one thing. Oh no, I can't lose anything. That's a completely different story. And then we have recovery time. Because one thing is when exactly I have my data, 5 minutes ago. Perfect. How much time does it take me to actually recover? Right? So, I have data from 5 minutes ago, but it takes me 4 hours to recover. Is that acceptable? It depends. It depends on our business. And so it's important also to think about performance. How performance is going to be affected in our application when I put DR? For example, I have my application running, and suddenly I go and say, I want to do replicas. I want to do merge replication, for example, with SQL Server. I want to do merge replication into another database. Does that affect the performance of my application? Yes. Why? Because merge replication is actually transactional. So it's going to stop everything else from accessing my database while it's doing the merge replication. So I need to consider these elements in order to make sure that the DR strategy I use do not affect my application in terms of performance. So I need to have background systems, async solutions in order to solve that. Then there is consistency. For example, imagine I have blob storage, I have SQL databases, and I have table storage. Is there any way that you know that I can back up all of them at the same time? I would love to, but there's not. I need to actually do them separately. What happens is, if I do this separately, what will happen is that potentially I might get one backup, which is 5 minutes ago, and another backup, which was a little bit later. That means that the consistency is not there. If I restore everything, I might have some consistency glitches. I need to plan for it. And then there's geographical location. Am I going to put my DR in the exact same data center, in the exact same zone? Will that help if the zone goes down, if the region goes down? Doesn't. I need to consider exactly where I should put. And so, just for a terminology standpoint, let's think fault tolerance is designing to incorporate the redundancy and replication. It's making sure that my application recovers from a problem. That's building the application on the application level. High availability is about measure my availability on my solution. It's making it highly available. It's saying that my application will continue to be usable, will always be usable, even during some problem. It's almost, in some cases, I can make high availability by deploying my application in 2 different regions and serving them from those regions. This will make my availability a lot higher. DR is just a process. It's just a process that sits on top of all this and creates the process, the policies, and the procedures that I will do if something goes wrong. That's DR. Everything okay until now? Any question? No? One of the things, SLAs. Who normally reads SLAs? It's so awesome reading SLAs. The amount of things that you're going to find in an SLA is absolutely brilliant. I read an SLA from a customer. Of course, I'm not going to tell who the customer was, but the SLA was, we're going to provide you 5 nines. And everybody was, this is brilliant. Those guys are brilliant. And they're in a very small line. There was, it's actually allowed, and it's part of the SLA, if I actually present a page saying we are having issues. Awesome, I have a 5.9 SLA. I go into a page and say, sorry, the application is not here. We're having issues. It's under the SLA. Thank you, SLA. You saved my life. So it's very important to read it, and it's very important to understand it. If we have a yearly SLA or a monthly SLA. For example, Windows Azure has monthly SLAs. What it means is that if they go by 1 month and don't actually use this 25 minutes, for example, in the cloud services, or this 43 minutes for storage and all that stuff, they cannot use it on the other month. In this case, on yearly, they can. So if I have an 8-hour outage, I have a yearly SLA. So everything went good. So it's different. And SLAs actually impact costs. Who would have known? One example was I went with a customer. They work in healthcare industry, and they build solutions for hospitals. So, and we started, and the first thing I asked was, what's your SLA? Because even from an architectural perspective, you should always know what's the business SLA, and then even go deeper and understand inside each feature, what's the SLA for each feature in order for you to design for full tolerance and high availability per feature. Because there might be a feature that if it's not there, I don't care. But if it's an emergency response system for my life support system saying that something is wrong, that might not fail. Right? So it's different. You need to ask. And in that case, I asked, and they said, I want to achieve 5 nines. And we said, OK, awesome. So we started to build the architecture. One thing that I like to do, and one of the things that I always recommend everyone to do, is actually doing the architecture and doing a cost estimation associated with that. Why? Because suddenly they actually weren't that interested in having 5 nines. Because for some reason they didn't like the number 2.5 million per year. Don't know why. They actually prefer getting something like 300,000 per year that would give them 3 nines. It was good enough. Basically, if you ask IT people, what's your SLA, they are going to tell you a huge number of nines, because they are not seeing the impact in the costs. But you need to consider this. So, and another thing is, when we use Windows Azure, for example, we're using several different elements. For example, I'm using cloud services, so I have 99.95. I'm using storage, I have 99.9. I'm using SQL Azure, 99.9. So what will I achieve? The max I can achieve with that is actually 99.75. Am I good enough with that? Does that work for my business? After that, after doing this math, you are going to understand exactly if you need to do redundancy, if you need to do in terms of the backups and the DR, what DR strategy to use. So with that, one of the typical DR approaches that we have is redundancy. We do redundant solutions. So instead of 1, we put 2. Do you know any example other than in IT that we use redundancy? Mountain climbing. There's one that I'm actually using tomorrow that I actually love the fact that they do redundancy. Thank you for the redundancy. I don't want to get in the water. Please, I want to get to my destination. Do they need actually that many number of engines? They normally don't. If you study a little bit of aeronautics, you actually will understand that they don't need that. But I'm really glad they have. Because if something fails, and again, something will fail, they have the other ones in order to make sure everything goes wrong and we end into the destination. Unfortunately, the last few flights were not the best flights I have ever had, because there was always a failure for some reason. So, but why do we plan for failure? Because hardware fails, software fails, people fail. For example, I was in Ryan Dunn and Wade Wagner's session, and they were telling that, okay, do you have, for example, do you have a build manager on your company? Someone that actually is responsible for doing the builds and configuring everything afterwards? Yes? Okay. So, never happened that that person actually messed up, for example, a connection string, right? Never happened. That never happens. It never happened to me, at least. It's like, how many of you do bugs in code? Oh, I don't. I do undocumented features. Sorry. So one of the things in the cloud data center, they didn't magically remove all this. They just created a way to quickly recover for them. In terms of people, what did they do? They tried to automate everything. From a build server, for example, we tried to automate everything in order to make sure there are least failures and people don't fail. We try to do stuff in order to software not fail, but they will fail. And so in order to design for scale, we need to think from this perspective that they rarely happen, but they will happen. And that's important, that our application owners will be the responsibles for this. And one of the models that I found that actually works is the DevOps model. How many of you use a DevOps model in the company? How many of you use an IT ops model where you have dev teams and ops team? The dev team goes and say, I'm code complete. And suddenly, that goes to the IT people. and they start monitoring. And then there's a support team. And suddenly there's someone that calls and say, there's a bug in the application. And you go to the developers, and the developer says, I don't care, it's code complete. For some reason, when you move into a DevOps process, which they are actually responsible for doing that, they actually care. Brilliant. They now care about the bugs they do. So actually, the code that they produce is a lot better. And also, balance the cost and complexity of achieving high availability and the level of DR you want. Is the cost something I can live with or not? So finally, one of the things, if I need, for example, I'm doing an emergency response system for a nuclear plant. Do I need high availability and a DR strategy in that case? Anyone? No? What's the SLA you would like to have in that case? 3 nines? Would it be enough? Highest possible. So in that case, I might be thinking about, I need multi-server, multi-region, I need multi-cloud. It's not something completely crazy to go multi-cloud. If you need to achieve that much availability and that much DR, you might actually need to go even multi-cloud and even having a third one, which is on-premise. Of course, that has costs, but we need to understand from the business perspective what is the impact, and based on that, we can plan. Okay, so after that introduction, let's go to DR options. What's our DR options? We have several of them. So cold, disaster recovery, warm, hot, and high availability. Everybody knows this, right? And the much I want, the more that I want, the more that I pay. Okay, so if I want something like, yeah, I'm good with a couple of hours, cold DR is good enough. It's the most common. The reason why is the cost is actually very, very low. The changes in code are very, very low. So it's the easiest point, is the easiest entry point. When we go to warm, which is more of the recommended one, we're talking about having something that is not, it's not being used, but it's there. If I need it, I can quickly, in less than an hour, I can quickly shift. If I go for something like, oh, around 5 minutes, I need a hot DR. I need something that is actually running and it's actually there. If I want high availability, which I will have a live kind of configuration, then I want something that it's already there, it's running, it's replicated. I can fall back from one to the other and the customer wouldn't even notice. This has cost impacts. So let's see. In theory, what we need for a cold DR is we have a data center. This can be anything. And we have our second data center, which only has some file storage. What we do is just what we always do. Do some backups into the file storage. And if for some reason that thing goes down, okay, I can basically put the package there. The application is running. Put the package backup is running. And put the package, put everything there, and everything's good again. And in some cases, this is really interesting because the cost is low. So I only have one site provisioned. I'm relying on my backup strategy in order to have this. So when we think from a Windows Azure perspective, one of the first things we need to do is use fault domains. Who knows what the fault domain is in Windows Azure? Who's hearing this for the first time? Okay, fault domains are basically a way that Windows Azure has in order to make sure that imagine you have two instances. am I going to put the two instances in the same server or in the same rack? Would that make sense? No. So by default, actually Windows Azure leverages fault domains, which basically says that when I deploy something, they won't be all in the same place. They will be placed in different racks. So if one rack goes down, I'm good, because I still have the rest. And this is actually configurable. I can actually define the number of fault domains that I want, and basically say, oh, I have 10 instances running, I have 5 fault domains, which means that I have 2 instances running in each different rack. So that will help me if one rack fails, I still have most of my application up and running and the power is there. Does that make sense? This is extremely important. It's part of the inside of Windows Azure. It's what makes them ready and built in order to support disasters and recover quickly. Another thing that we would do is, for example, backup SQL database. What would we use here? SQL database actually provides a capability which is SQL import and export. What they basically create is a backpack. Anybody already knows what's a backpack? Backpack. Basically, it's a zip file which has schema and data from inside my database. It's like a back file, but without the transaction log. So I have schema, I have the data, so at any point in time, I can actually pick this backpack, import it again into SQL, and everything is there. My schema is there, my data is there. I can quickly recover. And then, unfortunately, there's nothing currently out of the box for syncing and doing backups from the blob storage. But there are tools that actually provide you with that capability, third-party tools that you can leverage, and you should leverage. Okay, so another option is, this one is actually taken from a customer. And the way the application was done, they have a solution running in the cloud. The solution is fully running on the cloud. And their DR strategy was, in that case, if that thing is out for 2 hours, I don't care. It's not important for the business, so I don't care. But there was one important thing that we did in order to achieve this. Because we can recreate from scratch, at any point, exactly what's in the cloud without even doing backups. So what we have, we leverage fault domains. We have backups of the blob storage, but we also have the file storage there. But we leverage service bus. So every time the application writes into the database, we actually change it. And since we are using the repository pattern, we actually change it to say, yeah, write it in the database and drop a message in this queue. What this will do is it actually changes my database, my main database, which is on-premise. Because in this case, we were just doing, there is a big system, e-commerce system, on-prem that we couldn't change. And there was, in this case, a seat allocation. This was for an airline. A seat allocation solution running in the cloud, in Windows Azure. And so every time we allocate a seat, we would write into that database in the cloud, but we also would inform the ticket system that there was already a seat allocated. What this means is that at any point, if that thing fails, I can actually recreate from scratch, because my application, I can recreate everything from my database and send it everything there. The cost of this was from a DR perspective? None. Because the ticketing application was there already. The ticketing application already needed to have the seat allocation information. So by doing this, we have a DR, and the cost is none. And there are solutions for you to have DR with very low cost or even none. We just need to be creative. There is absolutely no reason why you shouldn't have a DR strategy for you. How many of you have VR? How many of you would like to have VR? It's extremely important. Another thing is warm DR. What's the difference? The difference is, while in cold DR, I didn't have anything already prepared. I didn't have a replica of my application running. In warm DR, I actually have. And so basically what happens is I have two data centers, and basically I have replication between them. And so this replication, for example, we can use SQL Data Sync in order to do this replication. And this replication won't be done every second, but so I need to play with my recovery time objective and recovery point objective. So how much time am I able to live if I lose a little bit of data, and how much time does it take to recover? So in this case, in a warm DR, I'm saying that I want to, for example, I can say I want 5 minutes. It's my RPO, and 1 hour is my RTO. And so I would have this solution. What happens is, if that one fails, the other one will be promoted. It's already there. Everything is deployed. Perfect. What happened? The only thing that might happen, my database was not completely the same. But it's a strategy. I decide if I can live with it or not. If I can't live with it, I will use something like a restore policy with my backups. If I can live with it, fine. And so when it gets back, everything gets synced again. And so in this case, warm DR normally use data replication. So they have a secondary already running, maybe a smaller one. That's what happens. But then the costs are minimal. From a Windows Azure standpoint, you would have, for example, North Central US, you would put your main application. And you will put your DR strategy in South Central US, for example, or East US, whatever makes sense for the business. And while on the primary, you actually have 10, 15, 20 instances, the number of instances you need, the other one might only have 2, for example. Why 2? Anyone? Full domain? Minimum SLA. Cloud services has the minimum SLA, has the SLA of 99.95 if you actually have 2 or more instances. Same thing with VMs. 2 VMs, you have the SLA. And so it's important to have that. So the second location, we would have that capability. We would have just a smaller level. It's like a pilot version, right? You have a little pilot running. If something happens, I have replication. So in this case, for a SQL database, what would we use? SQL Data Sync. We'll sync the data with SQL Data Sync, for example. We will leverage that synchronization. We have time. Again, don't forget your RTO and RPO. Because if SQL Data Sync wouldn't be enough, then we would get another another option in order to make sure that would happen. But this replication will allow us to have a synchronization between the data. And we would leverage another element from Windows Azure, which is Traffic Manager. How many of you know Traffic Manager? One at a time, please. Okay. Traffic Manager is a global traffic manager. So basically, we have a DNS. We define in there saying rules like performance, failover, and round robin. And it basically, we will define what are the cloudapp.net DNSs that I want to have in that traffic manager. What that will do is basically on what I choose, for example, failover in this case, you will check. There's a health check saying, oh, I have this application running on this DNS. Is it healthy? Yes. So I'm going to continue to hit the primary. Suddenly the primary goes unhealthy. You will immediately fall back to the second one. So it's giving this intelligence into that system. That's why it was built. So one of the important things is, how is your application going to know that it's healthy? Anyone? Do you have anything in your applications today that have a health check saying, is my application healthy or not? How many of you have? One. Nice. So is it important? So Windows Azure actually checks if some parts are healthy, and those parts are the infrastructure. Is the machine running? If I have a web role, for example, is IaaS running? It doesn't check anything else. Sorry? Yep. What I can do is actually, and what I should do, is actually create a service that actually can be hit by Traffic Manager, for example, and I can put, here's my health probe. Here's my health API. You call this, and the API will check what? Will check, is my application running? More than that, if, for example, I have an application that is running, and the application is good, but it's actually not returning any data because the database is down, is my application healthy? No. There needs to be a complete process. So that health check needs to have all the information from, is my application healthy? And that means my application is running, it actually can connect to the database, it actually can do something. And not only that, my application is healthy, perfect, but it's taking 10 minutes to get a response. Is it really healthy? No. So it's important when you do a DR, one of the things, and that's why it's a process, it's a set of processes and set of elements that you use. It's basically that, because it makes you think about these things. It makes you go and say, when is my application healthy? Oh, it's taking 5 minutes to retrieve something from the database. It's not healthy. Oh, so my goal is that every page or this page or this feature actually answers in 3 seconds. This one can answer in 6. This process should take the max this. And based on that, and based on instrumentation of the code, I can have all that information. And when I go and hit the health check, I can actually say, yes, it's healthy. And this is one of the elements that in Traffic Manager is extremely important. I always provide the health checker in order to make sure that the application is healthy. Because if I don't do that, the only thing it's going to consider is the infrastructure healthy? And if you want to test this theory, the easiest way to do is you just deploy a cloud service, and you know how cloud services actually are inside the machine. You remote desktop into the machine, go there, and you have a C drive, you have a D drive, which is temporary, and you then have another drive, which is normally the E, where your application is. Just do a simple test. Remote desktop into the machine, select everything from the E drive, and delete it. And then go and check if your application gets, if your instance gets recycled. What do you think? Will it? No. The machine is running, IaaS is running because it's not installed in that drive. Your application is not running. So if that happens, you have a problem. Right? So that's why it's important. So by leverage traffic manager, what we would do is immediately by having this health check, it will immediately fall back to the second region. And then I can, in the background, have a process saying, are my 2 regions up? No, so get the main one up and get there. And one of the important things here is that, for example, in this case, we have the second region, and this second region was only with 2 instances. When we switch to the second one, check that it goes to more than 2. What do I need to do here? I need to scale. I need to have a scaling process also in place. For example, I'm going from a pilot version into the full Steam 1, so I need to check that now I'm going to start receiving more and more requests. And the more requests I receive, I need to scale my application. For example, there is an autoscaler, which is known as Wasabi, that was built by Patterns and Practices, which is really good. But there are other products out there, third-party products, that you can leverage in order to monitor and actually put some actions like scale up, scale down. One recommendation is, how many of you first have auto-scaling rules on your Azure deployments? How many of you are considering to do that scaling something more than CPU and memory? CPU and memory are important, but they are not the only thing. It's important to get patterns. It's important to understand exactly what's hitting your website, what is hitting your application. For example, my CPU is 50%, my memory is around this level, but there are other elements. But I know from all the days that I've been going and using this, I know that normally by this time, it actually has a spike. So I can use that one also to influence my decisions. And know if I'm using this, for example, if I'm 60% of CPU, and I'm in this timing, which I normally know that it gets a spike, instead of just increasing by 1, I will increase by 3, because I know I'm expecting more traffic. So it's important for you to know also the scaling units, how many scaling units, because your application sometimes doesn't scale linearly. How many of you test for understanding exactly if your application scales linearly or not? Do you have applications that scale linearly? Is it easy? No. You'll get a little chunked graph. Sometimes by only adding 1, it's not enough. So it's important when you implement DR and this kind of approach that you have a pilot and then to scale, you need to have that. You need to have that notion of what exactly do I need? How do I scale my application? Okay, so basically this gets replicated in the database with SQL data sync, leveraging Traffic Manager in failure mode, and leveraging auto-scaling and providing, of course, this has higher costs than the cold. Yes, but if my business requires it, I need to do something. I need to know exactly what to do. The third one is hot DR. What is hot DR? It's something that is there already, up and running. It could even be that that node could even be the primary because it's so hot. It's so ready for it to start receiving everything. So for example, the concept is we have, again, replication. And what we have is if one fails, the other one will immediately pick up and will continue to work. So this is a typical deployment. It's costly. It's very costly because you basically have two exact replicas almost of the system. One is doing something, the other one is not. But you have this information. Normally, this is not very used, normally. So there are several options in here for Windows Azure. One option would be, okay, I'm leveraging fault domains and doing some replication with SQL Data Sync and some third-party tool in order to replicate also my files and my table storage and so on. I leverage Traffic Manager in failover mode. And if something fails, immediately my second region gets promoted. And since it's actually the same thing, it's not, again, it's not a pilot. Now it's the real thing. It's already ready, like exactly the primary one. It will immediately pick up. The recovery time is very, very low. That's why the costs are very, very high. So then the main one goes, and okay, I get the other one. Why would I use this? For example, all my customers are in North Central US. So I want my main one to be in North Central US because of the latency between the customer and my application. But if something fails, I want to redirect them to another region because at least they won't get that failure, that outage in my application. And when I get to recover my main one, I redirect them to there. The customer didn't even notice most of the times. And if one of the secrets is having your applications being decoupled and asynchronous. And embracing one thing, embracing eventually consistent solutions. How many of you use eventually consistent systems? How many of you use ACID still in your applications? ACID transactions. So if we, for example, say everything is synchronous, everything needs to happen in synchronous fashion, we are always going to have a recovery time. We are always going to lose something. If we decouple everything, what happens is that the surface of failures, if a failure happens, since I'm already in an asynchronous mode, an eventually consistent mode, customer won't even notice anything changed. Oh, I inserted something, but I'm not seeing immediately there. I'm already fine with it. For example, is Facebook ACID or is Facebook eventually consistent? What do you think? Eventually consistent. Twitter, same thing. Have you already did a status update on Facebook and then refreshed the page and the status wasn't there? Did that already happen to you? That happens. Why? Because everything is eventually consistent. Everything is going on the back end, and that's why that's how you do fault-tolerant systems. That's how you do highly available systems. It's embracing that eventually consistent. And then there was one really good talk around Windows Azure from, for some reason, Windows Azure from pulpit to boardroom or something, but was basically around highly available solutions One of the things that was done is, what about having the ability for you to replay everything that you did until now? If you build that from scratch into your application, you'll have cold DR, for example, at zero cost. And that is extremely important. So another option is, other than doing the replication, is we would do only the replication, the copy of blobs, but we would use queues. So we will use an asynchronous pattern in order to send data into the second one. So I'm saying here that my recovery time, I need something faster than DataSync, for example, provide. And whenever there's something I have Traffic Manager, and whenever there's something that gets stored, instead of storing only in the local database, I actually send the message in order to store it on the replicas database. What this allows me is actually to have a processor, a background processor that goes and retrieves. And I actually can scale up and down and can actually play with the time that I want in order to recover. Oh, I want this to be processed in less than a minute. Perfect. So I spin up more instances of that role that is actually receiving that message. So when this goes out, I can actually recreate everything and repoint everything because it's a lot faster that my data is there. And so in this case, we're replicating only the database based on queues, and we're having similar deployments in both of them. So the quicker, we have a quicker recovery time than the one before. Because now we can actually affect how? By spinning more workers that will play with the service bus. And the third and last one is another one that is so many times used, which is we have a replica, and check that in the second one, we have this backup happening. I'm not doing backups on the primary, but I'm doing backups on the secondary. Why? Because backups, if I do SQL backup, what happens while I do the backup? I do the backup, and then I start using the application. The application uses the database. What happens? The backup is transactional. So it will hold on everything, every request. I don't want to affect my performance, as we spoke in the configuration, in the considerations. So I'm using the backup only in the secondary, and in order to be sure that everything is there, my application actually always writes in two places, main one and secondary. Only if those two say it's okay, I will say it's okay. Your request was actually accepted. For example, if we think on the back-end SQL databases provide you with 3 replicas of the database. Primary, secondary, and then you have some more. What happens is that you are only going to receive an OK that your insert, for example, happened if the primary and the secondary, which are actually made synchronously, say, OK, are already stored. Only the third one is going through an asynchronous pattern. And why is that? Because if I want to recover quickly, I can actually point to promote the secondary into primary, and I'm sure it's exactly the same thing. And so this is the most costly out of the 3 options for Auth DR, but it's the one that I can actually fall back from one to the other, and everything will be there. Everything will be exactly the same. And so I can create the new one and be sure that everything is there. Does that make sense? Yes? Okay, so there's only one left. High availability. If I want to create high availability solutions, so that means I have 2 or more data centers running at the same time. They are always synchronized. They are serving everything. And this is a live configuration. And so when one goes down, I have 50% of my capacity that went down. All the traffic goes there, but I can quickly recover. I have the backups there. So if I think from a Windows Azure perspective, what I would use is Traffic Manager, replication. In this case, check that I'm not using SQL database. I'm using SQL Server inside a VM. The reason is SQL Server 2012 has a feature called Always On. Have you used it? Always On actually provide you with an active-active configuration, which is absolutely priceless when we think about high availability, because they actually can synchronize the two without actually affecting the performance of the application. And so this provides me with the ability to put Traffic Manager, which is, in this case, configured not as failover, but as performance. So I have two systems running exactly the same thing, running in two different data centers. If I'm now here, I'm going directly to the South US. If I'm in North US, I'm going to North Central US deployment, and so on. They are exactly the same. They are synced. They are in an active solution. But if someone fails, I won't even notice, because I will be redirected to the new one, and oh, maybe the performance went a little bit glitchy, but it's still there, and I can recover. The replication happens immediately. I always have two systems that are running at the exact same time with the exact same capacity in order to allow me to fall from one to the other with no absolute change for the customer. What would have known? This is actually the most expensive one. Who would have thought that? But it's actually, if we think about one of the solutions that we have in the company, we did for one of the customers, which is an emergency response system for a nuclear power plant. Yes, we actually implemented that. We have this, and I won't tell you the rest that we have, because there is even multi-cloud and on-premise failover for that thing, because we don't want to be liable if something goes wrong. Because actually there's one of our colleagues that lives close by the nuclear plant. So he said, you better be sure you do something really good, or I'll kick your ass. Okay, so conclusions. One of the important things is always plan for failures. There's one thing, as David Aiken normally used to say, there's one thing I will give you an SLA of 100%. Things will fail. I will do an SLA of 100% on that one. Other than that, no. Things will fail. Another thing, always talk to the business and IT. But talk to the business. Understand the business. What are the requirements? What are the recovery time objectives and recovery point objectives for the business and for the IT? Because the IT, the first thing that is going to tell, we have someone that on the booth came to us and I want 100% of SLA. I want a Ferrari. That doesn't mean I'm going to get it, right? There's no way you are going to have a 100% SLA. We can mitigate the process, but we first need to understand, yes, I want 99, I want 6 nines, 7 nines, whatever. How much does it cost? Does the business actually, can the business cope with it? And then what we have is also to understand from the business perspective, each feature, what's the SLA? Because different features can have different SLAs. For example, in our emergency recovery system, notifying everybody that there's some weird things going on, is pretty much a very high SLA. But for example, having the dashboard thing running, maybe that's not an important SLA. The notification is. But having a dashboard which they receive messages in, does that require the same level of SLA? No. So I might have, in the same application, different SLAs, and that will drive how I build my DR strategy for that and how I architect my application. Choosing the right DR is going to be derived from that. Cold, warm, hot, high available. There is one thing I always recommend, and I would recommend to all of you when you get out of here, is start putting in place your cold DR, at least your cold DR. That might be doing backups, but do it. The cost is none or very, very low. And there's one thing that we know, it will fail and we will need it. Some other important elements are infrastructure capabilities change. So this DR strategy is not something that you visit once and never revisit again. You will need to be continuously revisiting, continuous change, continuous upgrades in the DR strategy itself. Plan for the costs. Understand exactly DR. There are very cheap or no-cost options, but there are very expensive ones also. Check exactly what you need. Do continuous improvements and plan for DR. And there's one thing that you always should think. When you think about DR, you're going to make your application better. Because as we showed, that will make you think about process in your application that you normally wouldn't think. Like, I'm going to think, how much time is it going to answer me each page? How much time is this feature allowed to be offline? This will help the business define what's the SLA that I'm going to provide. And that might even create different business models. So by building a disaster recovery, you are going to do a lot more. You're going to affect a lot more. So do it today and be sure that your application is there. Thank you.